Very pleasant morning to my dear lovable students. I hope you all are safe. In this conversation, we are going to discuss about three important concepts and related example and exercise also. So, concept number one, elementary transformation of a matrix. So, in your book given three important conditions. So, condition number one, interchanging any two rows or columns of the matrix according to the elementary transformation of a matrix. Example, consider for 3 into 3 matrix. A is equal to, consider for A1, A2, then A3, then B1, B2, B3, then C1, C2, C3. So, according to the way, this is called row 1, this is called row 2, this is called row 3. This is C1, column 1, column 2, column 3. So, what it's saying, condition number 1, interchanging any two rows or two columns. So, according to the condition, C1 interchange with C3 means, what will happen? C1 interchange C3. So, C1 interchange C3. So, C2 as it is. Therefore, we can write it A is equal to, so what is not change? C2. C2, A2, B2, C2. So, A2, B2, C2. C1 interchange. So, C1 move on C3 as well as C3 it's move on C1. Therefore, A3, B3, C3. A3, B3, C3. C1, A1, B1, C1. A1, B1, C1. This is interchanging any column wise. So, column 1 to column 3. So, as well as we can change row 1 to row 2. So, how to change R1? Okay, I will take it. R1 interchange R2. What will happen? So, R1 interchange R2. So, R1 interchange R2. So, not change the row. R3 is in R3, C1, C2, C3. Therefore, C1, C2, C3 as it is. But row 1 interchange row 2. Row 2 means B1, B2, B3. Row 1 we can write it B1, B2, B3. Then row 2 we can write it A1, A2, A3. So, A1, A2, A3. So, this is condition number 1. Okay. I am moving to condition number 2. So, condition number 2, what it's saying, replacing a row or column of the matrix by a non-zero scalar. Non-zero scalar multiple. So, non-zero scalar means, so the multiple value except 0, that's why we are writing. So, non-zero scalar, whatever. So, according to the condition, if you take a constant value, whether lambda or k means, what will happen? So, just we have to apply the same condition. What is the condition? A is considered for 3 into 3 matrix. So, A1, A2, A3, then B1, B2, B3, then C1, C2, C3. So, this is, we know, this is called R1, this is called R2, this is called R3. This is C1, C2. So, this is C1, C2, C3. So, replacing any row or column of the matrix, non-zero scalar of the multiple row or column by a non-zero scalar. So, by a non-zero scalar means the value of multiplication value also except 0. That's why we are saying non-zero scalar. So, condition, just we have to apply R1, row 1 multiply with some constant. So, k into R1. K into R1, R2, R3 as it is. Therefore, we can write it. R2, what is the value? B1, B2, B3 as it is. B1, B2, B3. Again, C1, C2, C3. So, C1, C2, C3. But R1 each and every time scalar multiple the value k. Therefore, k into A1, k into A1, then k into A2, then k into A3. So, this is row wise. The same one column means just I have to apply C2 gives any one number value. So 3 into C2, what will happen? 3 into C2. So completely, so this is C1, C2. This is complete C2 we have to multiply into 3. Here also into 3, also into 3, here also into 3. Remaining as it is. So A1, B1, C1, A1, B1, C1, C3 also as it is. A3, B3, C3, A3, B3, C3. Here 3 into A2. So 3 A2, again 3 B2, then 3 C2. So this is condition number 2. Okay, I will move on. Condition number 3. Condition number 3, replacing a row or column of the matrix by sum of the row with a non-zero scalar. That is condition actually, sum of the row. Listen, there is an important condition. So sum of the row or columns with a non-zero scalar multiple of another row or column of the matrix. So just to consider for the 3 into 3 matrix set, what is the meaning? So A1, A2, A3, then B1, B2, B3, then C1, C2, C3. So now this is already we know R1, R2, R3. This is called C1, C2, C3, column 3. So sum of the row or column, sum of the row or column means, just example. So C3, you have to take it C3 plus, otherwise, so C2 plus, so non-zero scalar means taking lambda into C3, what will happen? Okay, so C2 plus lambda into C3 means, look at there, first C1, C2 as it is, okay. So C1, what is the value? A1, B1, C1, A1, B1, C1, then C2 also as it is, A2, B2, C2. So A2, B2, C2. But C3, C2 plus, C2 what is the value? A2 plus, again lambda into C3. Therefore each and every element you have to multiply lambda into. Here also into lambda. Here also into lambda. Therefore lambda into A3. So lambda into A3. Next condition also B2 plus, then lambda into B3. Then C2 plus lambda into C3. This is the way. Okay. This is applying for column. Okay. The same one to apply the any row means what will happen? So R1 gives R1 plus 2 into R2. What will happen? 2 into R2. So now, so R1, okay, R2, R3 as it is. So B1, B2, B3 as it is. B1, B2, B3. Then R3 also as it is. C1, C2, C3. So C1, C2, C3. What are the changes? R1, R1 plus. R1 means, so A1 plus 2 into R2. 2 into R2 means 2 into B1. Then A2 plus 2 into B2. The next condition A3 plus 2 into B3. Okay. So I hope you are very satisfied in this 3 concept. Okay. So I will continue some related problems. Okay. I am moving to second one, row echelon form. Okay. One of the important condition. Okay. But very simple. What is the meaning of row echelon form? When starting the non-zero digit. So the condition, when starting the non-zero digit under the term should be 0. The condition. So listen, I have given 3 set of 3 into 3 matrix set. I am moving to first one. Okay, 3 into 3 matrix. The condition, what is the meaning? When starting the non-zero digit. Here first one already starting the non-zero digit. Okay, except 0. So when starting the non-zero digit under the true term must be 0. Okay, that's condition. Then the same one, then if you move on the second term means this is column 1 considering column true, right side only will come to the non-zero term. If you come to the again opposite side, if you come to any number value, instead of 0 is there, any 3 is there, means any 3 or 4 here minus 2, whatever the value, definitely we can say this is not a row echelon form. Okay, that's why listen very carefully. There is 0 is there, isn't it? So right side we have to, it will be there, it should come. Okay, it becomes, that is not an issue. So when starting the non-zero digit under the true term should be 0, the first condition. Then right side will come, that is, we can say that is called row echelon form. Right side the one is there. Then when starting the non-zero, the second one under the term, look at there, under the term here should be 0. Then only we can say this is row echelon. Then if you come to the any third term, if you come to any number means after the 1, any right side only we have to come the any number value. If it come to here number value means this is not a row echelon form. Look at there, then you will get it more understand. Second 3 into 3 matrix set is there. First 0 term is there. So 0 means whatever it is, that is not an issue. But when starting the non-zero digit, where it is started actually second column, the first term under the non-zero term. So under the true term 0, that is row echelon form. Then look at their third means actually the third column, where is the non-zero digit, the second part, the 7 is under the term will be 0. This is the way. Then third one, look at there, when starting the, where is starting the non-zero digit, third column only. That's why the first one, second row completely, the first column, second column will be completely 0 when starting the non-zero digit under the true term. If it come to any left side, if you come to any number means instead of, there is I have put in dash only, instead of dash any number is there, any minus 2 or minus 4 means this is not a row echelon form. Okay, this is the comp, but right side we can come, any right side will come any number, that is not an issue. But row echelon form when starting the non-zero digit under the term, then if it started after getting the non-zero digit, right side only should come the value. Okay, that is the condition. Okay, row echelon form. Okay, so I will move on as per your book some concept also. Okay, so listen very carefully my dear students. Just I am moving to as per your definition 1.5 page number 17. 3 points is there, just comparing the point with this related matrix set also. Okay, listen, first one I told you row echelon form, what is the meaning, when starting the non-zero digit under the term will be 0. First starting 6 is there, under the term will be 0. Okay, then when it started the, where it started the next non-zero digit, second row, so this is no problem because starting the here second term continuously the whole term will be 0, because when starting the non-zero digit, the third term only we have started the non-zero digit to 1, under the term will be 0. So definitely we can say that completely the value will be 0 row. So when we will be started the next non-zero digit in third row means right side only will come. Okay, it comes to the left means definitely it is a not row echelon form. That's why I am saying next condition, this is definitely the completely row echelon form, because there is starting the non-zero digit 1, then under the term also will be 0. Check it there, next term, when starting the non-zero digit, second column only started. Okay, that's why the first column completely 0. When starting the non-zero digit, under the term will be 0, correct. Then second term will be considered here. Third, second row, last term only non-zero digit, under the term will be 0. Therefore, this is also row echelon form. Next one, 3 rows and 4 columns, isn't it? This is actually 3 into 4 matrix set, 3 rows. Now when starting the non-zero digit 1, okay, under the term will be 0. Then where is started row to the third part only non-zero digit, so under the term will be 0. Here look at the left side only the term. If it come to the any right side means definitely this is not a row echelon form. So here the third part only the non-zero digit, under the term there is nothing, because the fourth row also there is, they didn't give anything. So we can say this is completely row echelon form. Now last 2 matrix set, listen there, this is also not row echelon form, this is also not row echelon form. Why? When starting the non-zero digit 1 is there, under the term will be 0. Next one, so minus 2 is there, already I told you the second term, definitely we have to check it the second term, isn't it? The first one whatever it is, that is not an issue. Second one, third part will be third term will be non-zero digit is there. So I told you under the term will be 0, but right side only we have to say, we have to write some non-zero term, but here left side is there. That's why we are saying this is not a row echelon form. Next, last one, when starting the non-zero digit, listen, there the term also non-zero term is there, but here starting the 0 term. So whatever it is, second the next one, when starting the non-zero digit, 3 it started non-zero digit, under the term, first one, here also under the term will be 0, there is no 0, okay, but left side also number is there. That's why we are saying the last two sets, it's not suitable for row echelon form, okay. I hope you are satisfied how to analyze the row echelon form, okay. I am moving to the problem, okay. So I am moving to 1.13 question, reduce the matrix to a row echelon form. So condition, solution, the given condition. So 3 minus 1 true, minus 6 true, 4 minus 3 1 and 2. What is the meaning of row echelon form? When starting the non-zero digit. So there non-zero digit there, we have to show under the term should be 0. So what we have to do to make it for 0 means, first condition, so how to make it, here minus 6 there will be minus 6 means definitely, so minus 6 and minus 6 if added means minus 12 will come. So positive 6 means only 0, isn't it? So minus 6 plus 6 mean will be come out here 0, sorry my dear, the second term will be 0, first term as it is. So the second row, isn't it, R2 we have to make R2, there minus there, no, take it plus means it will be 0, because minus 6 here plus 6 mean will be added, 0 will come. So R2 plus, the next one, already 3 is there, 3 how to make it for 6, 3 into 2, isn't it, 3 into 2 means value will be 6, no, therefore we can write it 2 into R1, okay, R2 plus 2 into R1. Now next one, under the third row also will be 0. So what we have to do, minus 3 is a symbol, no, minus 3 plus 3 means value will be 0, no, therefore R3 definitely we can take it R1 plus R3, okay. First R1 as it is, what is R1? 3 minus 1 2, next one R2 plus 2 into R1, so R2 plus R2, what is the value? R2, isn't it? So R2 minus 6, then plus 2 into R1, what is the value? Already 3 is there. So next condition also, there 2 is there, 2 plus 2 into R1, R1 minus 1 is there. Next condition, 4 plus 2 into 2 only. What will happen? So 2 into 3 minus 6 plus 2 into 3 6, so value will be 0, but here, so 2 minus 1 into 2 minus 2, value will be 0. Next one, 4, 2 into 2, 4 only will come, that value will be 8. Therefore, 0, 0, 8 only. We can write it 0, 0, 8. Next one, R1 plus R3. Directly we can write now minus 3 plus 3, no. So, value will be 0. 1, listen very carefully, plus, no, there is already minus 1. 1 minus 1 is equal to value will be 0. So now 0, 0, 8, isn't it? So next one, we know R1 plus R3, so 1 minus 1. Now 2 plus 2, value will be 4, okay, sorry my dear, value will be 4. Now see, when starting the non-zero digit, under the time we have to already show 0 is there. Now next one, where is starting the non-zero digit, second one 8 is there. Here we have to show value will be 0. So what we have to do, R3, isn't it? Therefore, R3 gives, this is, we can rub, no? So, R3 gives, there already 4 is there, 4 means, there half into 8 is example, half into 8 means definitely 2 and 8 cancel means 4 will come. Therefore, minus of half into 8 means definitely we can say no, minus 4. Therefore, 4 minus 4 value will be 0. So, what we have to do, R3 gives R3 minus half into R2. remaining as it is. So R1, R2 as it is. What is R1 value? 3 minus 1, true. 0, 0, 8, 0, 0, 8. Now R3, definitely comparing R3 and R2, R3 minus R2. So 0 minus 2 comparing, definitely value will be 0. Second time also 0 minus 2 comparing, value will be 0. Third row R3, what is the value? 4 minus half into R2. R2 means value will be 8. So 2 and 8 cancel means 4. Therefore 4 minus 4 is equal to value will be 0. Okay. So 4 minus 4 value will be 0. Now this is our row echelon form now. What is the meaning when starting the non-zero digit under the term 0? Then second row third element non-zero digit under the term will be 0. This is, we can say, it is called row echelon form. Okay, I will continue the next example. Okay, be stay on the line. So listen, 1.14 concept same like example 1.13, but here matrix set surely. So row 1, row 2, row 3, but column 1, column 2, column 3, column 4. Therefore, we can say this is called 3 into 4 matrix set, isn't it? The solution, the term 0, 3, 0, 3, 1, 6. Then minus 1, 0, true and 5. Then 4, true, double 0. So listen. What is the meaning of row echelon form when starting the non-zero digit? But here, first term 0 is there, 0 term is there, but second one non-zero term is there. First we have to interchange, okay? So R1 interchange R2. R1 interchange R2 means already we have discussed in transformation, elementary transformation of a matrix. Because condition number 1, interchanging any two rows or columns, isn't it? What we have to do? Row 1 interchange row 2 means minus 1, 0, true and 5. The next one 0, 3, 1, 6. Row 3 as it is 4, true, double 0. So next term, now starting the non-zero digit minus 1 is under the term we have to show value will be 0. But third one only 4 is there. And second row already 0 is there. So but 4 comparing R1 means definitely minus sign is therefore what we have to do? R3 gives R3 plus only. So R3 plus 4 into R1. So R1, R2 as it is. R1, what is R1 term? Minus 1, 0, true and 5. R2, 0, 3, 1, 6. R3 plus R3 what is the term? 4 plus again 4 into R1 means minus 1. The next one 2 plus 4 into R1 already 0 is there. Next one 0 plus 4 into 2, isn't it? Next condition 0 plus 4 into 5. What is the answer? First one 4 into minus 1. Therefore 4 minus 4 value will be 0. Next one 2 plus 0 value will be true. Next one 0, 4 plus 2 into 8. Next one 0 plus 4 into 5, 20. Therefore 0, true, 8 and 20. 0, true, 8 and 20. So clear now when starting the non-zero digit under the two term you shown 0. Now next one when starting the non-zero digit. When starting the non-zero digit means 3 is there. So under the term we have to show value will be 0. So under the term means, so here 2 is there, isn't it? Just comparing again R3 minus 2 by 3 into R2 possible. So R3 what is the value? 2 minus again 2 by 3 into R2. Yeah, possible no? Into R2 what is the value? 2 is there no? Instead of R2 write it true. Sorry my dear, R2 value will be 3. There 3. Now 3 cancel. So 2 minus 2 value will be 0 no? So its proof is correct now. So what we have to do? R3 minus 2 by 3 into R2. So therefore R1, R2 as it is. What is R1? Minus 1, 0, 2, 5. Minus 1, 0, 2, 5. 0, 3, 1, 6. 0, 3, 1, 6. So next one R3 means R3 minus. So R3 minus R2. 0 minus 2. Comparing 0 means definitely value will be 0. Next condition already explained here. What is the meaning? R3 minus 2 by 3 into R2, isn't it? So this is the next step way, isn't it? So R3 already I have written 2 minus 2 by 3 into R2 value will be 3. Cancel is it? So we can write it directly 0. But next condition. So if you know thoroughly the concept, so no need to apply, okay, during the problem, okay. So in your, if you moving to the question paper, such a question is there means no need to apply each and every step, just directly, if you know thoroughly, just to do the step only, then write the answer directly, okay. Now the second one, next condition, R3 minus, R3 what is the value? 8 is there, minus, again 2 by 3 into R2, R2 what is the value? 1 is there. Therefore, listen, 8 minus 2 by 3 as it is, 8 into 3, 24 minus 2 by 3. Therefore, value will be 22 by 3. Here value 22 by 3. Next one, again R3, there 20 is there. Then 2 by 3 into R2. R2 means 6 is there. Therefore, 20 minus 2 into 2, 4. 20 minus 4 means value will be 16. Now next term, isn't it? So next step. Next step actually the term will be correct, row echelon form, but actually the third row, one fraction term is to convert for whole number means it's easy no to show the answer. So now what we have to do, each and every time into 3 means, so R3 completely we have to multiply 3 into R3, okay. R1, R2 as it is, minus 1, 0, 2 and 5, then 0, 3, 1 and 6, R3, 0 into R3, 0 into 3 means value will be 0, again 0 into 3 means value will be 0. Next one, 22 by 3 into 3 means 3 cancel, value will be 22. Already 16 is there, 16 to 3 means value will be 48. Now we can say no, row echelon form. Look at there, when starting the non-zero digit under the term. Then second row 3 is there, under the term value will be 0. Right side number, that is not an issue. But left side won't come to the number. So this is the way, okay. So I hope you are satisfied in this session. If you have any doubt, please put in comment box. I am ready to clarify your doubts, okay. I will continue the next session, okay. Bye-bye.